For this class module, we'll focus on discussion and discourse in the science classroom. An examination of discussion and discourse is important as studies suggest that question and answer sessions encompass roughly 80% of the communication that occurs in secondary science classrooms. That is, 80% of communication that occurs in the secondary science classroom typically follows what we call the IRE sequence of initiating, responding, and evaluating. In other words, the bulk of communication follows an approach that requires memorization and regurgitation of memorized material, with teachers continuing discussion only until a student answers the question correctly, at which point the teacher then moves on to the next question, thus making the assumption that if one student answers the question correctly, then all students have learned the material. So, is this approach effective? Well, of course not. It is considered non-effective as it limits students' abilities to understand science concepts as they perceive learning as a search for right answers, and thus results in only superficial learning. Therefore, students when engaging in this type of discussion are not required to engage in higher order thinking. And when students are not engaged in higher order thinking, the chances for meaningful knowledge making to occur decrease. And that, of course, results in decreased levels of learning, and many would argue decreased levels of engagement. As Tweed 2009 reminds us, to be effective, students need to participate in interactive dialogue with the teacher and with one another. Likewise, in order for students to engage in meaningful knowledge creation, especially in the science classroom, they must come to understand the ways of sense-making that are characteristic of scientific communities. What is meant by this statement is that science is a social subject, and thus science learning is a social activity. Consider how scientists function in real-life situations. They function in collaboration with one another, which of course requires effective communication. So, if we view science learning as a social activity, then we'll also realize that discussion and discourse are supported by a learner-centered approach. There are 4 basic kinds of communication: dialogic, authoritative, interactive, and non-interactive. Let's take a closer look at each. Dialogic communication involves strategies that utilize more than one point of view. In other words, more than one voice is heard as a variety of different ideas are explored. Thus, this type of communication takes into account students' voices, students' ideas, opinions, and so on. Authoritative communication involves strategies that focus on just one point of view. In other words, only one person's ideas, thoughts, or opinions are explored, and there is no exploration of different ideas. Oftentimes, the authoritative approach examines one scientific point of view. Interactive communication involves strategies that utilize talk that occurs in all directions. In other words, the communication includes talk between the teacher and the students, as well as between students, flowing in both directions. Non-interactive communication involves strategies that utilize talk that is unidirectional. In other words, the communication comes only from the teacher to the students or from a student to other students, but not in both directions. So, how do we best utilize discussion and discourse in the science classroom? Well, we can start by teaching students to pose science questions rather than just answer questions posed by the teacher. But how do students learn this? Well, by modeling. So it's essential that the teacher explicitly teach students and show students how to engage in scientific discussion and discourse by utilizing this type of language his or herself. As Chipetta and Kabbalah 2010 remind us, talk and argumentation are central features of sense-making in scientific communities and must be central features of science learning in middle and secondary schools. One of the major ways in which teachers can model appropriate use of communication in the science classroom is through the use of scientific argumentation. The National Research Council, as cited in Chipetta and Kabbalah 2010, defines scientific argumentation as logical discourse whose goal is to tease out the relationship between ideas and evidence. Thus, scientific argumentation is not a debate, but rather the communication that uses logic and follows the nature of scientific reasoning. Another way that teachers can model appropriate use of communication in the science classroom is through the use of talk moves. Talk moves are teacher questions and statements, as well as periods of silence, that encourage detailed student talk and foster student cognitive engagement. Examples of talk moves would include probing and redirecting. As cited by Chipetta and Kabbalah 2010 on page 184, probing is when teachers encourage students to extend, clarify, and justify their talk, whereas redirecting is when teachers encourage students to extend, clarify, or justify the talk of a classmate. Another way that teachers can model appropriate use of communication in the science classroom is through the use of talk formats. Talk formats include the creation of collaborative groups, peer pairs, and other group strategies that encourage engagement, thoughtful reflection, effective discourse, and then, of course, meaningful knowledge creation. Likewise, if we truly consider social learning theory, and specifically Vygotsky's viewpoint of the importance of social interactions to learning, we must also recognize that we learn best when we move from learning in social context and move to individual understanding. So, one of the goals of discussion and discourse is to not only have students engage in communication, but to also construct individual meaning. So let's look at some ways in which teachers can model and teach students to effectively utilize discussion and discourse in order to encourage thoughtful learning. Chipetta and Kabbalah 2010 provide some great discourse patterns and examples for us to review in preparation for practice. So if we take a look at their suggestions, we'll see that one discourse pattern that teachers can use is the I think blank, will blank pattern. An example is, I think the metal will emit an orange color when placed in the flame. Another example would be using the blank, had blank, so blank format. An example would be the plants had received no water for 4 weeks, so they died. How about the discourse pattern of the blank is blank because blank? For instance, the substance at the bottom of the beaker is a salt because a salt forms when an acid reacts chemically with a base. Or even, this blank is similar to that blank because both blank. For instance, the forelimb of the bat is similar to that of a human because both have the same kinds of bones: humerus, radius, and ulna. Some additional examples are shown on your screen, such as, this blank is different from that blank because one has blank and the other does not blank. Or the main idea from this observation text passage is blank. Or this blank is needed for blank because it blank. I would encourage you to pause the video and review the examples provided for each discourse pattern. In conclusion, collaborative discussion should foster deep thought and critical thinking. It should follow a logical progression of thought, and it should lead to individual thinking and meaning making. In order for students to engage in the learning process and to construct individual meaning, these collaborative discussion facets must be present. The use of discourse and communication in the science classroom is inherent to the nature of science, and with thought, careful planning, and of course practice, they can be effectively used by the secondary science teacher.